The expert on fuzzy logic insisted that it is statistics. The expert on statistics insisted that it is fuzzy logic. Neither camp's representative embraced it. Instead, each chose to consign it to the other camp. So, is anyone studying this field that I'm for now referring to as statistical logic? I would be very surprised if the answer is no. Surely someone is studying it. But to find out who, and by what name, I find that my only option is to put together this multiple-part presentation on everything that I have so far figured out about statistical logic, in hopes that someone might point me to where it is being studied and by what name. Hello, Internet. This is Sophia, the Red Angel, and in part 1, linked to in this video's description area in case you missed it, I discussed a form of trinary logic that is a prerequisite to the concepts of statistical logic. That trinary logic examines individual cases. In this part 2, I will be discussing how individual cases get aggregated into whole sets as a start of what I am calling statistical logic. Of course, I will most earnestly be getting into statistical logic in later parts of the series. In this part, I will focus on how hopefully large sets of individual cases can be used to sum up frequencies of something. Basically, in any individual case, in this trinary system of logic, a statement can have any of 3 truth values: true, false, and non-applicable. But what if we are analyzing a whole set of cases instead of just one? Then what is the frequency of the statement being true? Generally, the approach to take is that the frequency of the statement being true is the number of cases in which it is true divided by the number of cases in which it is either true or false. For example, let's take a statement A. Let's say we have observed 6 cases in which A is true, 4 cases in which A is false, and 3 cases in which A is non-applicable. What we do is divide the number of cases in which A is true, in this case 6, by the number of cases in which it is either true or false, i.e. 6 plus 4, since it is false 4 times, which makes 10. So the frequency of A being true is then 6 out of 10, or 60%. Of course, you might wonder, how exactly does one observe a case in which something is non-applicable? To answer that, let's go to another example. Let us consider an example from part 1 in which we have observed several cases in which statements A and B are each either true or false. Only now we will enumerate how many cases we found of each. Let us say we have 12 cases in which both A and B are true, 8 cases in which A is true and B is false, 15 in which A is false and B is true, and 2 in which both A and B are false. What are the odds that if A, then B? Well, for the numerator, we take only the cases in which both A and B are true, because that is the only scenario in which if A, then B is true according to the trinary logic system that we have to use as a prerequisite. That means 12 is the numerator. For the denominator, we add that same number to the number of cases in which A is true and B is false, because that is the only scenario in which if A, then B is false. That means 8. The remaining 2 rows in which A is false, those we disregard, because in those 2 rows of the truth table, if A, then B is non-applicable. So the odds that if A, then B amounts to 12 over 12 plus 8, or 12 over 20, or 6/10, or 60%. I tend to be getting that figure a lot today. I promise I did not do this deliberately, at least not on a conscious level. But anyway, so far we have been calculating the odds of things. We have not yet done any real statistical logic. For that, we need to be able to make actual inferences of more values based on the limited ones that we know. And for that, it is not enough to discuss probabilities of specific statements, but to discuss dependencies between things. I will get to that in part 3. I will link to that in this video's video description area when that part is released. So until next time, see ya!